All right. Hello. Welcome to my stream today. Today I will be talking about SSR, or I guess server rendering in general, SSR, SSG, whatever SS abbreviation we want to go with. While I'm waiting for some people to join on, I guess I can talk again about some current events. Not that there was as many, I'd say, this week compared to last week. Last week there's a lot of conversation. It feels like it just kind of carried over. All the discussions around MPA versus single page apps and whatnot, still kind of ongoing. Not a ton new here. I forget if I mentioned it last week, but we're seeing more and more frameworks add like an MPA mode or announce that they're going to add an MPA mode. So I guess we're going to have to see how that goes. But yeah, you know how it is. Other big news for Solid was Netlify joined on as an official sponsor. You're going to see some deploy with Netlify logos coming in pretty quickly here, and having some extra money in the bank is definitely going to help us set up some of the legal properties and things we need to do to get this rolling. You'd be surprised how much actually other stuff needs to come in. We don't want someone stealing our name on us. And other than that, another really cool thing, I don't know if you guys got the chance to check out Party Town. It's from the creators of Quick and Mitosis, Builder.io. And it's basically a way of getting all those pesky analytic scripts off your main thread and putting them on another thread. It's actually really clever how it's implemented using a proxy and synchronous XHR requests. So they basically block the web worker thread so that they can synchronize, keep it in sync with the main thread. But it's fine because then the main thread doesn't get blocked, so your page loads quickly and it just works for you. And yeah, I mean, probably worth checking out. And actually, probably one of my favorite things this week was Swix did an interview with Sunil, a former core team member for React. And honestly, just listen to that whole thing. They touch on so many points, and it's completely on point. From discussions about React server components, and I thought there's some really insightful stuff there, carrying on from what we talked about last stream, where essentially SEO isn't really the consideration there. It's not about server side performance or anything. This is a means for them and their teams to be productive, kind of like micro front end kind of mentality, where they can, if stuff makes sense on the server, do it on the server and whatnot. So yeah, it's just kind of interesting to kind of hear someone, closer to it say that out loud, because that's what I suspected. But, it's amazing when you think of what it does for the development experience, especially for things like Next.js. Where you don't need to pull in a GraphQL or whatnot. But on the other hand, it's not quite the same as being done with multi-page apps and the work being done with Marco or Quick, like I mentioned a few minutes ago. So it's definitely check out the podcast. I was called the thief, but in the best possible light. So I quite enjoyed that. Yeah, if anyone's out there, say hi in the chat on YouTube. Let me know you're there. All right. Yeah, so less stuff to go off at the beginning here. So I guess if that's about it, I'm going to share my screen and start talking about server-side rendering. Oh, hey, thank you guys. Yeah. It's good. As I said, it helps me when we interact and stuff and ask questions along the way. It helps me know what to explain, because I didn't mention this stream yet, but it's pretty impromptu. I don't have a ton of stuff prepared. I just have a lot of material that I can share. I've been working on this stuff for years. So, if you have any questions about Solid or even not about Solid, shoot. I had to study a lot of stuff to figure out how to make this all work. And server-side rendering, as you guys know, is a huge topic. Monumental, and that's actually a good place to start, because when I built Solid, I was not thinking about server-side rendering at all. I was really trying to create a framework in Knockout's image to a certain degree, like just, primitives that you could build upon, good patterns in terms of composition, and then, showing that it could be performant. I think I mentioned many times before, a lot of benchmarks came out around 2014, 15 that like basically destroyed these kind of, they used to be called key value observable frameworks, KVO, like Knockout, even Ember at the time. And I wanted to build something that, had good performance. I could tell like the update performance is so good. So I felt like there's something we could do there. But server-side rendering was not even on the map for me, honestly. I didn't really see the point. I'd only worked on application-like things like, which I call it, like I worked in social media, private social media for education, like photo sharing, and like so you could have the kids and the families engage and the teachers and stuff. And it was behind logins, and I just never had any use for server-side rendering. And a lot of the kind of myths or thoughts that people have about it, there's some truth in it, and I think I'll get into that a bit today. But when I built Solid, I was like, okay, let's just see how fast we can make a client-side framework. And what I found was actually really fast. When I first kind of was putting these demos together, if you notice, a lot of like my real world demo and original Hacker News demo and all of those were only client-side only. They were beating server rendered like Sappers and Next.js frameworks at Lighthouse scores, like first paint. You're just like, how is that possible? And the pure client-side rendering. And the reason is, historically, server-side rendering, it's been done pretty crappy. I mean, I don't know, no sugarcoating it. It's just, it was just a very kind of simplistic approach. And it's not about just like raw speed or performance of server-side rendering. It just simply the fact that architecturally, the way we've approached it as single page apps, isn't as good as it could be, right? Like this is why Jamstack got popular, to be fair. If you have like an app shell and you load some JavaScript and then render it in the client, as long as your network is relatively fast, most places in North America, Europe, it's perfectly fine. Client-side rendering is going to beat your classic render everything on the server and then ship it. It is. It seems surprising because it's just your time to first byte is going to be faster because your page loads kind of immediately, and then what happens is, like, sure, some stuff might take a while to load in, but the biggest problem with server rendering is when you wait to send all the content till you're done, you can't preload the scripts and stuff. And by the time you take hydration and stuff into consideration, your whole load time is actually longer and slower. And I'll actually show you guys what I mean about that in a few minutes. But I was basically just trouncing server rendered frameworks with client only rendering. And I don't think it was unique to Solid. I just had more consideration around parallelizing fetching and code splitting stuff than a lot of like naive approaches would. And like you can still see it to this day. If you pull up the real world demo, and although it's down right now because they had some cores issues with their backend, but if you pull it up and do the Lighthouse scores, Solid's still one of the fastest, and it's a client-only rendered representation. So it took me a bit to get one over on server rendering, and what it really comes down to is slow down that network tab and see how things change. So I'm going to show more detail what I'm talking about in a bit, but suffice to say that server-side rendering beyond SEO also can have performance benefits, and if they're in the right sort of app, if it makes sense to have it. And I think most people aren't actually building closed gate, logged in, like want to be a mobile app, things like I've always built. I think the vast majority of people are trying to make, interactive websites and not everything's behind a login. So and in those cases, actually, there's probably different techniques you should be looking at as well, which we can also get into. But essentially, at some point, I changed my mind. I was like, I'm going to look into server rendering. That was about 3 years, 2 years ago, 2.5. And that completely changed the approach. So the question is, okay, if we're going to start server rendering, where do we start from, right? And for me, that started from kind of, I thought, I got a client-side framework. What if I just, went in and used the DOM, right? Because I don't know if you guys have ever looked at what Solid compiles to. I love the playground for this, but it's pretty minimal in terms of DOM operations. And you can see, I've got a button here. I didn't really show it too closely, but button here, you click it, it goes up. The way Solid works is we clone a template, and then we basically keep your code, and then the JSX just becomes like clone that template, adds click handler, make an effect around the dynamic part, and insert that element of the DOM. So I was thinking I could do this, and I actually, for the longest time, when I was like not caring that much, I said, hey guys, let's use JS DOM, and I did that, and it just wasn't really the best. Is the best way I can put it. It was really quite slow, and I could actually feel how slow it was. So I realized I had to rethink my approach here a bit. And what I came up with ultimately is rendering to a string. And if you guys want to see what that looks like, I can show you pretty quickly here. In some ways, this code is not unlike what we saw a moment ago. If you look at this right off the bat, you can actually see our signal still getting created, and we can see a template, but now instead of it being, like the HTML template, it's actually an array of string parts with holes. And all we do is basically pass that array in and then pass in the holes. This is the reason it looks like this is I actually started this as a tag template literal. And then actually I found out that the tag template literal using it was actually slower. So actually just calling it as a function and not as a tag template literal actually improved rendering speed. This is a note, if you're on the lit team and you're working on SSR, maybe this will help you. But essentially, it looks kind of similar, except we just have some other things. We add a hydration key, which I can talk about in the future. And then we have to do some escaping on dynamic parts. But essentially, things just become strings. And the process here is just adding the strings together. I'm actually going to make this view a little bit bigger, just to help people see stuff. If we go in here, we're not going to actually spend that much more time in the playground, to be fair. I just wanted to kind of give kind of an overview of what the compilation looks like. There isn't actually much more to it, right? If we can add some divs and, whatever, got a div around it. We're just adding more stuff here. If it's static, like class equals hello, we'll just, get in our section here. And it's basically, we just gather up the strings. How about let's add another component here, because the funniest thing is the compilation isn't actually that different than you might expect, because we want the execution to be the same on the server and the client. So like if I make a button function here, component, and let's return button and put props children in. Actually, I mean, we probably actually just want to do this, right? Spread on props. But as you can see here, we still do the same like getter wrapper thing around this. And, components actually compile almost identically. And then there's just a few different helpers, right? Where this one's SSR spread. On the client side, it's just spread. So small differences, right? These kind of just almost directly run the effects on the elements. Where on the server-side rendered version, this is the client side I'm showing you right now. On the server-side rendered version, we're essentially just kind of like lining them up to go into this basically equivalent of a tag template literal function. All right, so it's funny because it actually took me a while to get here, because Solid is actually a little bit tricky in this area, because if you notice, this stuff imports from SolidJS Web, and I actually had to figure out how I wanted to handle this, because I wanted it to be isomorphic. I wanted what you imported to work on both sides, but there's some funny things here. Like, we don't actually need reactivity on the server. This is the other secret that I figured for performance, and I'm going to go a little bit more into like what that means a bit later. But we actually have different versions of Solid for these different cases, and I can actually show you this. I'm gonna share my VS Code window here right now. Let me use a switch. I'm actually doing the stream completely from a my MacBook. It's an M1, and essentially, stuff's a little bit small in here. Let's blow it up. Essentially, to avoid, like, you know, the infinite loop look thing in the screens, I actually have to jump windows a little bit awkwardly, because if I look at the chat, it actually ends up getting into the streaming view. But okay, so I've shown off DOM expressions in a previous stream. I'm actually got Solid here in front of us, the repo, and there's a few packages in here. There's the Babel preset, which wraps the plugin, Solid Elements, Solid SSR, which is actually just for now just a utility around doing static generation. But what I want to show is inside Solid source here, there's a few folders, and most of these submodules that can, like, the main one, stores, they have like a server thing. There's like a server folder, a server TS. And that's because Solid, by using something called conditional export maps, which, let me show you here. No, not here. Here. Something using, see this big chunk of exports here. This is a feature that they added late node 14 and into node 16, I think, where basically, this is also how dev works in Solid, by the way. Basically, tied to certain keywords, you can import, you can just directly map which, you know, disks you import or output. And if you look for all of these, I have development for the dev scripts. I have browser, and then I have node and the default. But there's a server version of Solid. So I actually have a different version of the library for SSR. And it's actually true for all the main library pieces. And to get, basically, I wanted to remove the reactivity from Solid, because nothing needed to update on the server. And even after I moved to string rendering, and I just used the normal reactive runtime for Solid, I was doing this benchmark made by Marco called the Isomorphic benchmark. I'll show you that in a minute. But I was basically getting scores that were like 70 or 80% of React or Preact. So like they would score on a test for me on my old machine like 400 or something, and Solid would score like 270 or 300. And I was like, oh my God, like, I guess I can accept that this approach is just really bad for you know, performance on what do you call it, on you know, fine grain doesn't really work with server rendering. But then I looked at what Svelte did and Marco, and I realized that they weren't doing anything special. They were just, you know how they use like simple language, like Svelte uses let. They literally were just passing the let straight through because they knew it would never update. They basically just avoided the reactivity, and I was like, huh, I wonder if I could do that. Obviously, I had challenges because I wanted to do serialization. I wanted to do suspense on the server and a bunch of other, you know, tricky stuff. But I realized that I could do that if I changed the rendering model. a bit. So big work that I did about a year ago, yeah, maybe a little less than a year ago. Like the last thing for 1.0 was kind of unifying all the server-side rendering mechanisms. So anyways, my point is that we have different versions of Solid, and to give you an idea of what it looks like, if you were in like the previous reactive session I did before, the create single implementation here is going to look a lot like the first thing that I showed you when I was teaching you how to create a reactive library from scratch. Because there's no reactivity. It's the TypeScript definitely muddles what's going on here a bit. God, does it muddle it? Okay, because it's literally return a function that closes over value, or do a setter. This is because we support function setters. Actually, that gets a little bit nasty, but essentially, or the setter, set the value equal to that value, or call the function with the value. A little bit nasty, but my point is there's no reactivity. So the like reactivity, like computed, is literally set a context, call the function, close the context. And by doing this and the string rendering, I was able to actually like you can just see all of these are just so simplistic. All these functions is like batch, call the function, because there's no need to batch, right? On mount, on cleanup, or just no ops. This actually helps even with like dead code elimination. Not that it's a big deal. I don't know if you guys noticed in the playground earlier, the click handler disappeared. Like the server, you're not counting bytes anyways, but it's just you know how it goes. But basically, through doing this, I was able to get the performance I was looking for, and I just kept on fighting at it and fighting at it. You know, I wanted to really kind of showcase the approach once I realized that reactivity wasn't going to be the bottleneck. So what I ended up doing, I'm just going to share my Chrome screen again, is what ended up happening was, let me see if I can pull it up here. Sorry, I don't have this prepared at all, but it's under my own profile probably. Excellent, let's do this. Isomorphic UI benchmark. No, but I want my version. Okay. Second, sorry, I'm just gonna pull this up. I was able to take what I had done and surprisingly got pretty decent results. I was very close to Marco or Inferno. And then somebody from the Solid community was like, hey, Ryan, I think the escape algorithm you're using, which I actually grabbed from Svelte originally, is not very fast. And they actually submitted a community submission. And the end results were incredible. This is actually kind of the latest to kind of give an idea here. But this is going to give you a ballpark. Sorry, am I on my branch? Yeah, so I need to go on to updated. It's really kind of incredible. I tried to test all the popular frameworks here, and I don't know if you guys can see this. Tell me if you guys can. I can blow it up a little bit more because it's a lot of text, but just to kind of get an idea of where this landed. Sorry, hide. There we go. Like basically they're two very simple tests. There's one that does a search results page that's basically based on a page from eBay, like the search results, which being Marco, it makes sense why they did that. And the other one is like a simple color picker that the Marco org always has on it, where you can just like change some colors. Both of them, one is kind of just like a mini kind of app thing, and the other one has a huge amount of static text because like footers and all this stuff, right? This is designed so Marco can show off its rendering speed, right? Because then you can see that Marco is about 8,000 operations per second, where something like it's like 10 times faster than React or Preact. They're like 900. And when I was running Solid originally, I was getting like I'd be getting like 600 or 700 here, right? Vue and Inferno are definitely nice bump ups, right, over React, right? And even Svelte too. They basically using kind of better rendering techniques. Preact and React are actually kind of the dogs on the server side rendering side, but Solids, I got like completely different range of numbers. It was once I fixed that escape, it was like an X3, and so similarly for the color picker, Inferno is actually pretty good here, but I actually found that they have a bug in their escaping for attributes, which is actually what puts them out front of Marco here. But again, it's the same story again. This one, which is less static HTML and just a kind of a small app, you can kind of see that, React and Preact are in this 4,000 to 5,000 range, and Marco's this time only, 5 times faster, and Vue's double React and Preact, and Svelte is like, a little bit better there. Solid's like over double them and 10 times Svelte. So server-side rendering with this approach is incredible. Marco had some old comparisons, and you can basically think of it very similar to like Pug or Handlebars. Like basically, we're literally just concatenating strings and getting rid of all the extra overhead. Of course, these examples are only static render, not static rendering. These are only synchronous rendering, and there's a lot more to SSR than that. So I'm going to get into that here in a second. Does anyone have any questions so far? Sorry, I've been talking for a bit. Need to wet the throat, so to speak. Just need some water. Okay, well, let's dig into it a little bit here then. I got a few examples, and I thought it would be fun to, and actually I'm gonna share my screen here for a moment, the whole screen, because it's just gonna be easier. So ignore the, let's just share the whole screen. All right, just to get into the code here. I've got an example project that I've been doing in the Solid SSR repo here, and it's my good place to start. It's a very, very simple example. Basically, I created the one application, and then I used 4 different render techniques to do it. This is kind of the problem with SSR in general. Everybody has a different use case. It's really difficult. And when I was looking at this at one point, I was like, am I going to need 16 different implementations? Like I actually went through the permutations of like what the optimal thing was. And I was like, holy, like there's too much. I've managed to kind of over time narrow it down and come up with strategies. And I think it really comes down to, a couple of things, but essentially, depending on your use case, there's you might want static generation, and then there's different types of SSR. Do you want synchronous SSR, where kind of like you render the app shell and then have the client do the data fetching? Do you want async, where all the data fetching happens to the server, or do you want streaming, which is kind of the best of both worlds? And it actually depends in some cases, because there's trade-offs that we can get into. But basically, my basic site here was something super simple. And this router is not even like a real router for this example. I just literally threw something together. But the idea is, on the client side, the code's always the same. It's just you hydrate your app, right? But I made a very simple app where the entry point, and this is something I've been playing with recently. I'm sure I saw Remix run. I actually can show you something kind of cool with this. But we start from the HTML tag, and then we can insert our assets or hydration scripts here. And then here's our basic router. There's 3 pages. There's a home page, a profile and settings, and then I wrap it in suspense. And then I have a basic router in this example. I have a more involved example I might pull up in a minute. I put a script tag on the page with async, important. This is how it's non-blocking for streaming. And beyond that, these routes are lazy loaded. the home and settings. Profile's lazy loaded too, but I used an older technique that I used to use where I have a synchronous part that loads as part of the project where I actually do the data fetching. And then I fetch the data and lazy fetch the profile at the same time. This is important because it removes waterfalls. If you do the data fetching inside the profile component and you wait to load it, you have this terrible pattern where you go to the next route and you actually have to like load the page and then have the page do the fetch. So it's like a double cascading waterfall. And these are the kind of things that you'd find super common in a lot of a few years ago in a lot of like SSR frameworks. And part of the reason I had these kind of patterns all the time on the client side, I was doing so well with purely client side rendering because I just kind of built this into my patterns. But essentially, I kind of have this data wrapper around the profile component, and the profile component itself is just another kind of thing. It's worth showing that in this data component, I'm doing 2 cascading fetching. So this is kind of like a waterfall situation where you load the user and then you load the user info. And I'm doing this by using the user as the check in the first part of create resource. I've kind of gone over this before. This is static, so it always just runs. But for the second one, if you have a resource that's null, and then it doesn't fetch. But I wanted it in this case, and this made it a little trickier for server rendering. I wanted it so that it could load this one, and then only once it's loaded, hence has a value, then it loads the other one to kind of simulate waterfalls that happen, you know. And this way you can see the effect of the waterfall both on the client and the server in these examples. So what I ended up doing, and then I got the console log just to prove that what's happening, what I'm saying is happening. Essentially, there's 2 of these loads using the load info. And for that reason, the profile, we say that we can draw the profile once the user's information is there, but then we have because there's a suspense wrapping the whole route. So the lazy loading and the user being loaded are part of that outer suspense boundary. And then the info is only being read in the inner suspense boundary. So you can, once you have the user, you can show this part, and then you'll see the loading info, and then this will come in, essentially. Hopefully that makes sense. Yeah, data fetching on the server without reactivity. Yeah, I will get there. Yeah, so essentially, as you guys know, data fetching on the server is actually the only thing that is kind of like reactivity. But here I had the revelation moment kind of at the same time. I was just telling you how fast Solid's client-side render is. So actually, I'll take a moment to explain this a little bit. I showed you how it was basically, I didn't tell you this just to brag. The reason I was showing you that it was like 10 times or 14 times or whatever faster than React and Preact was the cost of putting the string together isn't that expensive. So Solid's renderer on the server is actually almost top down. Essentially, the resources are kind of reactive, but we don't have fine-grained reactivity. When we suspend with a suspense boundary, we actually re-render everything under the suspense boundary again. We have a way of keeping track of the resources so we don't refetch and do that kind of stuff, like a bit of a caching mechanism, especially because, and we need it anyways because we serialize the data and send it to the client or serialize it in some way, so we need that cache anyways. But essentially, Solid on the server works more like React, just with no diffing. In the client, that would be just freaking bonkers because you don't want to recreate the DOM nodes. But think about it. Like how much your page is going to re-render with this, and how much wasted rendering are you going to do? If you get to a certain point of the suspense boundary, you'll have no info to render, so you're just going to stop there anyways. So maybe we take another 10 or 15% overhead for doing a little bit of re-rendering of the strings DOM without diffing or without anything, but it's just string rendering. So like I started doing the math and I was like, look, what's the worst case that could possibly happen here? Like at worst, we have to render the whole app twice. We're still going to be 5 times faster than the competition. You know what I mean? Like it doesn't actually matter. And that's sort of what freed me. Sometimes performance can actually change the question on the design when you feel comfortable at a certain level of performance, right? We talk about like removing component boundaries and stuff, and and this is a slightly different conversation, but it kind of came up, about, people saying, oh, you're just showing this thing where Solid removes the components and the performance thing because, you just want to show that it's, performance matters. I'm like, no, I'm saying performance is why we can remove the component boundaries. We don't have to rely on things like memoizing around components and stuff. If you guys don't know what I'm talking about, I'm sorry. It's just, I wrote an article called Components Are Pure Overhead. And we talked a lot about performance, but the real point of the article is actually about developer experience, saying that if you remove components, like as a thing that matters for updates, and you can just freely organize code however you want, that's incredible for developer experience. And it's only having such great performance that lets us get away with changing that, because otherwise, like in a VDOM library, you actually need the components to do the updates, and if you misalign those boundaries, your performance just tanks, right? I don't know if you guys saw Vue 3.2, and part of the reason that Vue 3.2 jumped performance so much in the JS Framework benchmark is they added a memoization mechanism similar to like React Memo. See, so it matters for VDOM. It's kind of funny that like in a reactive library, you want the least number of components as possible. Like, and if you start getting too many components and wrapping them, you start having to make more reactive context if your framework's based on components. If your framework's based on components, that's the unit of change. That's the thing that needs to like have the observer, the effect wrapped around it. So like MobX with React or Vue or Svelte. So you don't want to have more components, but in a VDOM library, it's the opposite. The more components you have, the more granular you can update the change when you memoize. So like for a framework like Vue, it's like conflict. It's like no matter what you do, you're going to get bad performance, right? But Evan geniusly came up with a solution for that using the memo, because that way he could keep the giant components that were good for reactivity, but then he can still memoize sections of the VDOM the way you need with the React library. Sure, it's like an advanced optimization technique, and you still have to be conscious of it, whereas in a fine-grained reactive system, it just works. But at least, there's a solution there. So anyways, I know that's a weird analog to make. I just wanted to kind of throw it out there so you guys can kind of understand. Sometimes if you have a good enough performance, it's actually liberating because it gives you more things you can do. Sorry, a little spiel. Back on topic. So let's see what this looks like, right? I'm just showing the simple version of the demo. The first version I'm gonna do is SSR. This is kind of like, you can picture this almost like Jamstack. It is dynamic, but if it was static, like I don't have a static version of this type of rendering in my examples here, but you can kind of view this as the Jamstack example if Jamstack served dynamic pages. So let's just do this, right? Okay, so refresh the page. You can barely see it, but there's a slight load here. We have a counter. There's suspense on this and transitions. I didn't show you, but you saw that because this next tab has to load data. So, oh, what happened there? Sorry, that was weird. Yeah, there we go. You can see the counter still counting. No, something is weird. That is interesting. Yeah, anyways, you can see the counter still counting while it's transitioning. I might have to look into that. Maybe I did introduce a new bug. I've been working on reactivity a little bit recently, and I could watch into that. Anyways, and then settings. This is just another dynamic thing. These settings and homepage don't really matter much. You get server render, then you can do some stuff. But the profile page, that grayed out is like the transition. When you load it, see? Suspense into suspense. So user loads first, then this. And if we look at our Chrome tab here in the console, you will see that we load user and load info right here in the browser. And actually, let me change this slightly. I'm gonna put the logs on here so you can see that nothing's happening on the client. Sorry, see nothing on the server. and the client's doing the data fetching. So, yeah, like let's just profile this. Oh, right, because this I'm not in an incognito window. God, Grammarly just kills me. See this hook.js? Just so terrible. I actually probably have an article where I actually have the exact benchmark numbers for this exact test. If anyone's interested, what was it? Rendering SSR optimizing for performance or something. Yeah. Yes. Yeah. So, yes. Let's see if I can blow this up big enough. Yeah. You know what? I mean, this is not going to do what I want. You know what? Let me just switch windows here for a second. It's just better if I do this properly. Okay. Oh, I see. I'm still actually using all this. I forgot that I was in like full window mode. Sorry about that. Okay, so you guys can see this. Sweet. Let's get back to what we were doing here. Yeah. Okay. Cool. So let's quickly just do a start profile and reload. Okay. Okay. What do we got going on here? I haven't actually ran this in a while, but essentially what you'll see in this sort of timeline, it's all here at the beginning, is oh, I see, right. You won't see another problem with this one, we're not actually doing real data fetching. So you can't actually see the data fetch. This isn't a good one to show off the timeline. I forgot. I'm doing simulated data fetching using a timer. So this doesn't actually show the data fetching, which is what's missing here. But essentially, you get first paint and first contentful paint like really damn fast because it synchronously renders, and then profile loads in and stuff, and then yeah, this isn't going to show on the timeline. I'm not going to worry too much about this, but the key point is that the work here is happening on the browser after the fact. On a fast network, this loads pretty quickly because the first page loads fast, and then we're just running our data out. Sorry, let's go here. The way this app works with SSR, just for your information, is I just call render to string. This looks like classic React stuff you've probably seen before. It gets an HTML string and it just sends it. But you can see the loading state. Now, I'm going to show SSG for a second because honestly, nothing really beats SSG in terms of performance. Actually, I'm going to build. First thing you can tell with SSG is when you build SSG, we're going to see data requests happen at build time because it actually requests right now when it builds it. And then when we start SSG here on the stream, it's going to have a slightly different behavior. This, you don't even see it flicker. You notice that? You see the 0 go to 1 and the page doesn't even flicker. And the reason is that the browser holds the page. Essentially. So since this page is rendering fully complete, when you do, and this is true for MPAs and all that stuff, basically, if you don't, until you send that content over, the browser is going to try and hold the previous page, which means you don't even see it refresh. And it's the same thing here. You can't even tell. So obviously, if you have the data ahead of time, static generation is going to be amazing. And Yeah, I know I said I wouldn't, but I just can't help it. You can just see that compared to what we had previously on our last little run, the static page is it's untouchable. We have all the paint events happening in the low 20 milliseconds, and then the full load here. And the only reason is it still takes a moment to hydrate, but compared to the client render, which needs to still do like some fetching and stuff to finish, it can just beat it out. Yeah, it's unfortunate that I'm not. Yeah, I'm surprised. Sorry, I want to try one more thing here, but you can. SSG is just the best baseline, but obviously we don't always have the ability to use SSG. Let's go back to our SSR example and try this one more time. Yeah. I just zoomed in too far if you guys didn't see it. The page isn't actually done. Like stuff isn't actually done until about the 899 second mark. The main content loads in after that first request right here, the paint. But basically, the benefit of this app shell with SSR loading on the client that I was talking about previously is that it can start loading assets right away. And it does take a moment, but we end up, being done at our, wherever this is, 870 something milliseconds. Okay. SSG obviously isn't comparable. Let's compare it to something else. I want to show you guys async. And what async is, Solid has another render mode. Which is build async, which basically waits until everything's done. And I usually am not a huge fan of this mode, although this is the most common mode in frameworks. Like if you pick up Next.js, this is how, and SvelteKit, this is how they work. Actually, most of them work synchronously, but they combine it like a fetch and then they do it. But if you wanted to, sorry, it's not stream, it's start. Yeah, see, async is almost the same as SSG. You don't see the flicker, right? And this is good sometimes for if you have some requirements for that kind of thing. But let's do the profile here. Okay. Do you see what happened? I told you there's two 400 millisecond requests. The async wasn't able to show the content until it was done. So look when it's actually done. Like we're not even getting anything painted till 800 seconds. So this is a kind of extreme case, but I just want to kind of show you the difference here in terms of what the experience is. Yeah, okay. Let's actually look again, because we have both of them. Let's look back to our SSR example here, because I was probably unfair to it a little bit in terms of timeline, because I think, yeah, that blip, that's just a weird blip. Yeah, so this one finished at 8:51, and there's some variance here, and async finished at 8:54. So it's not actually that different, to be fair. I mean, and obviously local computer and stuff, but I just like, this is the difference between the app shell and the wait to render, is that you just don't show anything till the end. And to do that in Solid, our async starter looks like render to string, async string, and we await it and we get the result. And if you notice, the fetching is happening on the server now. not on the client. And so you might be like, well, how do we do this? Well, let's actually view page source line wrap. We flowed out one of these lovely scripts, which does a few things like capture event listeners while it's loading and a few other nice stuff. We actually kind of do this like event capture, pre-hydration, then playback. But hydration resources equals first name John Snow info here. So you actually see the serialized data right here that we load in. So on an async, that's what that hydration script does. It actually serializes the data into the page, and it's there right when it starts being loaded because it does all the work ahead of time. Okay, sorry, some questions coming in. Oh, you guys can't see anymore? Huh. Crap. That was like 5 minutes ago. It's funny because it thinks that I'm sharing, but you're actually, oh, that's funny. I'm sorry about that. I'm gathering you guys can see my screen now. Sorry about that. Luckily for you guys, I was mostly talking and you didn't actually miss anything other than me showing a bunch of graphs. I'm going to I'll show you what I was talking about. You guys lost me while I was basically showing the different examples of the loading, and I was trying to basically when I moved to the into the incognito window. Can someone confirm that you can see this window right now where I'm showing page source? Still can't see. Interesting. Okay. Okay. Okay, let's try this one more time. Entire screen. Sorry about that. Okay, so you guys can see it now. That was so weird. Okay. Okay, sorry about that. Okay, so let's just rewind the last 5 to 10 minutes here. Okay. Yeah, I showed the layout of the project, and then what I was doing was I was basically loading stuff in the browser. All right, so going back, okay, so the SSR project essentially is set up here using render to string, very similar to what you'd see in React. And I'm going to kind of walk around in here for a second. Not that one, sorry, this one, okay. All right, right. So you guys can see the cascading loading, you can see it move and stuff. I'm gonna just start this whole section over here again. So I'm gonna use the profiler here for a second and kind of show you the behavior of how basically the different versions of Solid's rendering work. In this case, this one, if I view page source again, or actually, I've got it right here. Essentially, it serializes loading into the page, essentially, because it only does the synchronous part of rendering, and then everything fetches on the client. So you can actually see every time we reload this page, the load user, load info. So I'm just gonna kind of give it a little whirl here in the profiler, and might as well stop it now. And you can kind of see the characteristics here. We have two 400 millisecond requests happening that I'm simulating. You don't see them on here because they're not real, they're simulated. But essentially, our page gets, the outside of our page gets rendered pretty quickly here, like 34 milliseconds in. And then essentially, after the first request comes in and loads the majority of the section, you have this longest contentful paint event fire, which happens, what here, 449 milliseconds. And then the second event doesn't come through to finish rendering it till about here. And our JavaScript execution kind of ends around 839 milliseconds, right? So but you'll see like stuff like during this time period, you know, if you look at the timeline, because of like fave icons already loaded, the lazy loaded stuff is already loaded for the page, because what we have here, I already showed you guys when I was going over the app. Hopefully you guys did see that, that we lazy load the profile component. You guys did see that, right? Yeah, okay. So essentially, because we server rendered and sent it to the browser as soon as possible, we were able to load all this stuff. And then the client, after it loads the script, starts the requests, which takes a little bit of time, right? It was about 39 seconds. And you can see that delay all the way throughout, both when the first request comes in, and then finally about 8:39 when we're done. We basically, everything's offset by the amount of time it took to load that initial JavaScript. And that's kind of the characteristic we have when we're doing the static render. So you can kind of think of this like Jamstack, if that helps, in terms of perspective, because while they don't do the dynamic rendering on the server, it's kind of the same. You have this app shell, and then the client kind of picks up the rest of the data querying. So next, I'm going to do async. And async is similar, except it's a wait for render async string. And in terms of behavior, async, everything is available, but it takes some time. Actually, you know what? You guys missed me showing static. So I'm going to show static for a second. So let's actually do static. Let's do static first. This is, if you watch static here, if you look at my build at the, I'm going to build it again. Sorry, let me build static. Build static. You guys probably didn't see this before, but the requests actually happen on the server at build time instead of in the client, instead of the client or on the server. So with this version, you guys probably had no clue what I was talking about. That's hilarious. Sorry. If we just sit here and kind of refresh the page, you can't even tell the page refreshed because of like the browser holds the navigation, and all the async waterfalls are happening like on the server. So everything's been, it's actually at compile time. It happened ahead of time. And the difference is, if you look at the page source, where this just has some event capturing stuff before, I know this isn't very readable. I can add a little bit of size to it, but when I refresh this now, what you're going to see is we now serialize the data into the page. There's this hydration resources piece and a unique identifier, and then we get first name, last name, and then we get our interesting data. So Solid automatically takes the resources and serializes them into the page here. And then the client actually, on initial render, essentially when it goes to go, hey, I need to make that request, it's actually just goes, oh, I actually already have all the data here for the initialization here. And it knows because it can use the same ID. You can think of this ID the same as create unique ID, that like Solid has like a create unique ID helper. We basically use that on the resources to match them up on that first render. So it just skips fetching them on the client. And the only tricky part, and it's surprising here, is, and I'll show you in the timeline here. Let's do a performance profile now of this one, of the SSG. It's like so fast you don't even see it. I'm just gonna stop it because it's so fast. In SSG, this is like the idealized form. Obviously, you can't always do this. But if you look at this one, first paint happens even faster. I mean, there's some variance here, but instead of being what the last one was, like 34 or something, this one's like 28. But my point is, look, profile still has to load, code split load. So hydration doesn't happen until after the profile loads, but favicon comes in as soon as it can, and we're all said and done. Like the majority of the JavaScript execution is done at the 40 millisecond mark, right? But my point here is that obviously nothing beats SSG. All the work's done ahead of time. You don't have to wait for the fetching. But what I'm getting at is, what's really cool is we automatically handle code splitting. So we pause and stop hydration and auto serialize the resources. So like basically it just loads like this perfectly without you having to do anything, more or less. This is a good baseline, but as I said, my focus is more going to be on dynamic stuff than SSG, just because, I mean, we'll talk about SSG, but I just wanted to kind of show the difference between the different rendering techniques and why they're relevant to people. Okay, just making sure you guys are still here. You guys can still see my screen, yeah? All right, I'm going to keep on going. Okay, so let's do async, because async, now when I build, it's going to be different. You're not going to see the request here. But when I start async, the difference is when I refresh the page, again, it's like SSG. Do you notice that? No flicker, no nothing, no loading states, no nothing. But requests are on the server, not in the client, compared to the SSR before. But one thing you'll notice is, look at the favicon, if you can see it in the corner when I do this refresh. See how much longer that is? Listen, this is kind of a cascading situation where I have two 400 millisecond requests, but I want to really highlight the difference here in this kind of scenario where you have like data coming in, cascading requests and like, long fetch. In reality, those would be like probably less than half, but I just kind of want to highlight this right now. So let's show what async looks like. Okay, perfect. This is a world of difference. Nothing loads for the first 800 milliseconds because it has to wait for all the data to come in to even load the page. And what I was getting at is, this is how like Next.js and SvelteKit and pretty much every current SSG solution works today. There's a reason that Solid's client-side render stuff was doing so well when this is the competition, because if you look at it, it's not just, it actually affects the total time. Like this didn't even do it's first paint until after the client-side rendering was all done. It's 20 milliseconds to actually draw anything longer, and the client rendered, or like the synchronous and then client fetch version had the nice, you could already had the shell, you already had the favicon, you already had like the page loading and the loading states. This took longer to even show anything, right? And as this is what I kind of talk about the state of SSR. And the reason is, it couldn't even start fetching the profile of the hydrate. It couldn't even start fetching any of this stuff until after it sent it, which was based on after the data was sent. And again, it's because we serialize this data here, and it has to be all present at that time. So, and you see it's all server rendered into the page here. There's no loader. There's these long IDs. If you think these IDs are long and nasty, I actually did a version where I like uglified them into like short little strings and like hashed them up and made them look nicer. But you know what happened? They gzip first. So this is actually smaller because I use a lot of dots and like zeros and stuff. Like this actually gzips actually quite well. Just side note. So if you're wondering, if you come with a request to come up with like shorteners here or something, just think about that, because like unless your hashing compression is better than what gzip can do across the whole file, then you're probably not going to do as well. Anyway, just a side note. Where was I? So this is what most SSR looks like. So I showed you Jamstack. Now I'm showing you Next.js essentially. They do it a little differently. And this is Next.js with solids render, not with React, which we already kind of. But let's look at the next thing. Okay, yeah, you can see all those phrases. Well, I think there's only one left, which was let's build stream. Yeah, okay. Let's start stream. All right. Well, the behavior of streaming looks a lot like that initial synchronous server-side rendering one, right? You see the loading placeholders, and see the suspense hold, and sorry, I mean that's the thing. You can see the loading spinners come in, but here's the thing: the loading's still happening on the server, not in the client. So if you want to view the page source, oh, that's cool. The page source actually updates. It shows the whole. It shows it completing, so you actually see what streams in, which I actually didn't notice before. We actually flush down markers to tell that the resources are like the register the resources in the client, because we don't have them when we start streaming the rest of the content. And then as the resources finish, we serialize script tags to send the data across. This is what I was talking about, solid streaming solution being half and half. We don't actually stream HTML today. It's ideally, if we're streaming HTML, you could send the HTML along here, and you could actually have it slot into the place, replacing those loading indicators before your runtime even loads. But I didn't prioritize that for a couple of reasons. First of all, Solid is single page app primarily. So stuff isn't going to load until it's like you can't do much with it until it's going to hydrate anyways. And hydration is a guarantee. So generally speaking, for it to render at hydration time is not a big deal, right? Like, I mean, it's still better than client-side rendering, because technically you started the requests on the server, which means you didn't have to wait for the response to come back to the client to start those requests. And when you get the data, like it basically, like we basically sped up client-side rendering, and we know we have to hydrate anyways. It's a little bit different on an MPA framework, I think, or with stuff like React Server components in the future, I guess, though I don't know how that plays in. But essentially, in the case of something like Marco, we might never hydrate the lazy loaded content that comes in. So actually, like streaming it in without the runtime is beneficial, because you can actually get 0 KB JavaScript, where this approach that I have today doesn't give you 0 KB JavaScript. It still relies on client rendering. So it's kind of a hybrid. But it's still good enough to illustrate my point here of the benefits of streaming, because let's reload this. What about that? First paint, same as we've been getting, around 30, right? But look, like the client-side one, we got the load stuff ahead of time, like the profile and the fave icon. But because the data request started sooner, it came back earlier, right? And I'm sorry, actually fave icon still took its time. It really just waits till the end. Well, there's some paint task here. the actual JavaScript execution time for hydration and stuff all happens around 8:13. If you remember, like you can actually almost visually see this on the timeline. I guess technically the longest contentful paint is around 8:38. But my point is, streaming is faster than all the other solutions, or very similar to client-side rendering performance. It is faster than the async, like the Next.js's of the world, because it doesn't push offloading those resources, but it basically just gets both benefits. You get to load the data sooner, and you get to load the resources in the browser sooner, and then everything just works. And what's beautiful is you just get both sides of it, right? You get the automatic serialization, the suspense on both sides, the loading states. It's really where you want to be. Why can't, okay, question came. Why can't you do 0 KB with Solid's current approach? That's funny. The answer to that is, well, you could, but how should I put it? 0 KB for like being advertised right now in frameworks that are not Marco or Quick or Svelte are like basically like not including the script tag on the page. Like it's kind of all or nothing, because like you need to load the framework to get the routing to like to rent, like to do the hydration, like it's top level from, so it's kind of all or nothing. Whereas like in something like Astro or Marco, I guess technically speaking, when they're in 0 KB mode, it's the same deal. But my point is like, how should I put it? Like it's incremental based on the JavaScript you need. Whereas in a single page app, like the way Solid works and what, you kind of need it all. But I guess more pointedly is the current version of the streaming streams the data, not the HTML. So if you look here, loading is actually what's being sent over. We're actually sending the fallback over, and then it's being client rendered. So this is sort of half and half. We get the speed benefit of streaming the data, but essentially we're still client side rendering the holes, so to speak. So this version that I have right now works very well when you know that you're going to hydrate anyways. But if we didn't load Solid script, it would never leave the placeholder with the approach that I have right now. I hope that answers the question. Like it basically, we still need client rendering for this current approach to work. This is one of the things that's on my list to address this fall. But what I did want to, the key part to understand though, as well as this though, is that the performance is still quite good. Yeah, it's hard to, the outstanding timeline doesn't show, but essentially we kind of get the best. Like this example is a little bit exaggerated, but in terms of database latency, but also network latency can change it too. The biggest benefit, but I basically showed how streaming is basically faster than async rendering. But there's a couple more things that I want to show before we move on, related in this vein. And I want to go back to our simple SSR example, and I want to show you, this is the one that does the Jamstack style, right? I want to show you how crazy different this gets when we decide that we want to do fast 3G. I'm not even talking slow 3G, fast 3G. Let's run this again now. Let's see what happens in our nice client side example. Yeah, so everything is kind of ballooned out. I'm actually trying to think of the client side example. You know what? Actually, I can't do this part of the demonstration on this example because we're not doing real network requests. So we can't see the impact of the fetches here using simulation. I'm going to have to pull up a different example to do this part, essentially, because the slowdown is not going to be visual. I'm pretty sure. Look, let's. Yeah, we're not going to be able to show this. I'm sorry. The simulation is great for showing the fast speed, but for in terms of simulating network requests, I need to use actual network requests. So let's. I actually remade this example again in a different repo, and I think it's actually might be nice to kind of open that one up because it's a more advanced version of the same example, and you guys can probably see a little bit more there, which is, what is it? Solid SSR workbench. Ding. All right. This example is almost the same, except this time it uses Solid App Router and it inlines placeholder tags and it does real JSON requests. The only challenge for this one, I imagine, is in terms of what do you call it? Fetch caches naturally, which kind of makes it a little bit awkward. So we might not be able to see what we need. It might be best if I just go back to the article and actually pull this one up in the article. I'm in an incognito window there. Give me a second. Let's just do this. All right. This one ended up a little messier than I was hoping for here. For the because I basically ran a very similar example when I was doing this, and I was showing that like async had to wait till the end, and that with streaming, like the whole time was earlier. This is kind of what I was showing before, but let's see if I can load this timeline here. Yeah. Oh, right. It's because let's just duplicate this. Dev2, as much as I love writing on it, it has this really awkwardness that when you load any images, it essentially just takes over your tab. So you have to like open them in a new tab. Yeah. So this is the difference, because I kind of showed you how client and streaming had an advantage over async rendering on fast networks, but if you go on a slow network, the kind of opposite happens on your timeline loading. And this might be a little bit hard to see, but let's zoom this in. With streaming, essentially, when the network's really slow, suddenly it's taking like several milliseconds for the page to load. Now we're not even getting the HTML back until 600 milliseconds, and we're loading in our profile and our index JavaScript because we have preloading in this example now, and essentially our first paint doesn't happen till 1200, but there's a little bit of time here. But basically with streaming or async, at this point, because it's taking this long, the data is already finished fetching on the server by this point. So whether you use streaming or async, you can just render the whole page almost immediately. And you can see this is streaming. There's no gap anymore. Even though like these look like they're in time, they're actually sitting all on top of each other. Basically at this point here, around, between these points here, between like the load happens where the red line is. I don't know if you guys can see it, it's really small. And the first paint here, basically around 1300 milliseconds for the slow network, we've essentially loaded everything on streaming, and async would have basically the exact same profile. But on the client rendering, like the Jamstack version in this scenario, at that 13 milliseconds, yeah, it loaded the app shell, but now it has to go do the data requests here. See, these are the data requests coming in. And these aren't long data requests now in this example. They're actually like the ones that I was showing, like they're just against like this JSON placeholder thing. But because the network's slower, they take longer to come back. And you're not done till about 2600 milliseconds. It actually takes twice as long for a client-side rendered thing on, I think this was, quote, fast 3G network. So essentially, in my examples that I was giving in this article, if you do want to read about it in the server rendering performance article, essentially client-side rendering or client-side fetching and rendering and streaming are faster than waiting for everything to load on the server generally on fast networks. But on slow networks, async and streaming are almost indetectable, but client-side can be like double or triple, like your performance tanks. And when I realized this is when I knew that I had to do server-side rendering for Solid. Like, it's one thing, to kind of sit here and be like, oh, my network is fast. But if for people who need page loads and stuff, this is vitally important. Something like if you can't do static and you need to do dynamic fetching, doing it on the client for a slow network is like a death sentence. It's like it's just not even close. So the only way to get the best of both worlds is streaming, and that's why I think everyone will be doing streaming. Like it's kind of it's just a no-brainer from that perspective. That's why it's so important in React 18. That's why I originally did the first implementation of streaming over a year ago, and as I said, it's not complete yet. And Marco and stuff like this is the next thing on SSR. It affects MPAs and SPAs just as well, because it's faster on all networks. The problem is not every platform supports it. Cloudflare is one of the few ones that supports it for serverless functions right now. So I'm excited about that. Also, node servers do that. But I've been talking to people. I don't know if AWS will support it or whatnot, but I'm hoping with React Cloud, people will like have to start supporting streaming. Marco's team's been kind of shouting this at the top of their lungs for like years, but it's definitely underrepresented. I was actually doing a bunch of demos with Marco and kind of trying to show it off, and I was like, oh, where's the loading state? And it was like, oh, it's because like I don't think Heroku supports streaming, maybe not, or whatever setup I had. So you have to be very kind of conscious of that. That do it basically is just the best in both scenarios. I mean, from a pure performance perspective, which is something I tend to care about. So sorry, it's a little messy, but does that make sense so far? I just wanted to kind of show this and how does that streaming work in Solid? I forgot to actually show you guys what the streaming example looks like, but it's actually kind of cool. It isn't actually that different. Let me look at the index here. Pipe to node writable. In this one, I got a manifest for preloading compared to the previous app I was showing you, but the same idea. Where, for SSR, it's like, where is some build files? It's, rendered a string, then we have rendered async string, and then we have for the SSG and the async examples I had here, and then finally for streaming we have pipe to node writable. There's some few more options there, but essentially it just takes your render function and takes your response stream. And there's also a pipe to writable, which is what we use for Cloudflare, which technically I guess would work on if you made a version of Solid that worked in well, then don't have to make a version, but if you like, I don't know, want to stream from like a service worker or something, probably run Solid in a service worker. It uses the web stream standard. So that's more or less like the API there. This example has a few more features, so maybe I can show them off here. In that we show off our no hydration script as a way of loading in preloading tags. And then this is our hydration script. It's just this thing that we bootstrap that. And again, this is a how should I put it? This kind of rendering from the head isn't necessary in Solid. You can use like the string and then the usual input. It's just something I've been playing with recently. Of course, the question you might have is like, doesn't this affect stuff hydrating from the document? And the answer to that is actually kind of cool. Let me show you what happens for hydration from the document. I knew the playground was good for something, right? Let's do this. Yeah, we can still generate the output without importing the libraries. That's fine. Now, if this was normal SSR, or sorry, normal client-side rendering, you'd have this giant like script, right? But we can do a little better than that. And the way we can do that is, let me show you. Client-side rendering with hydration. Oh, it's gone. Basically, there is some code, extra code for hydrating from the top, I suppose. But it's minimal because we know that this starts from HTML, so it can never, or includes HTML tags, so it can never be rendered in the browser. So basically that whole higher level template here, we know automatically not to ship. And then essentially we have some shortcuts which jump to the head and jump to the body tag. There is a little bit of extra body walking because it needs to like handle these slots. But generally speaking, we have this ability to kind of remove that. And you see this link module preload? If we know that this is never going to come in, I actually added a directive to Solid where you can just go server only and bang, the template just disappears. I don't know if you guys saw that. So technically speaking, you know, you could have like a 0 kilobyte JavaScript thing with Solid if you wanted to, or like obviously, but you could also have like poor man's islands, I call it, without really doing anything, because you can just render your HTML page. You can even do it in JSX here like this, and then you can just put in put in whatever components you want, and it basically just won't ship the template for the main HTML page and just ship the code for those components. So, I mean, it's not fancy like Astro, but it's also like no effort. If you really wanted to do that, to me, I don't call this partial hydration. This is, I'm sure some people would be calling this like partial hydration mode or something, but I don't consider this real partial hydration. But it is just interesting that if you want, you can basically tell any template not to get shipped to the browser. And automatically the top level HTML template will not get shipped to the browser. So, you know, if you ever see something like this minify, you'll understand why this is important, because a lot of this code, you know, shrinks up pretty nicely or gzips pretty nice. Like how many times do you write the word next sibling here? But these strings, that's like, you know, larger apps and apps with larger static content, that's where all your code is. Because like, look, if we didn't have this hydration tag here, like blip, right? If we didn't actually have stuff that needed to be interactive, you know, stuff is all just, you know what I mean? Like one of the interesting things about this approach that Solid uses to hydration, which we haven't talked about much, is that we separate the template creation from the walking and adding. And this is true even for client-side rendering. If you know, it's like it's the same pattern where we do the separation. So what that means in general is that we only add as much hydration code as we need to hydrate. Like it's only as much code as you need. Like we don't need to like, it's not like the same concept of like re-rendering the component. Like we don't need the view code in this case. We can peel it all out. All this code is just walking to the elements and adding the stuff there. Like, I mean, this is overly simplistic, but if you had a completely static template, what in here is not static? Oh, it's probably these classless selectors, whatever. Yeah, because these are stateful. Like if you actually, that's why this didn't minimize. Like if you had a actually static template in Solid, oh, where did all the code go? Right? Like, yeah. Like, yeah. What? Oh, this is already not even there because we're not using it. Anyways, you get what I'm saying, right? Like, yeah, it's interesting. Pure annotations maybe fix this. This is funny because create single is not used, so the thing's smart enough to know that it doesn't need to be there, but it thinks it might produce a side effect, so it's there. But I think there's a way to make it even get rid of this create signal if you wanted to, but neither here or there. But you get my point. Essentially, this is why I've kind of held my opinion that with the proper partial hydration solution for something like Solid, and this ties back to the beginning conversation we're having about React server components. You might not need something like React server components to lazy load or not send the templates. Do you know what I mean? Like stuff like that, the components aren't allowed to be stateful. That's technically for React server components. So they're basically like API routes, at which point, if you just had a way of identifying the static parts and not sending them, then you basically get the same effect because we only send as much code as we need to hydrate. Okay. Hopefully that makes sense to you guys. You guys aren't as talkative this time, less questions. I hope I'm not just like saying something like way out there. All right. Yes. Yeah, because I'm gonna go on, I guess, to the next thing then, if there's no questions at this point. All right. So yeah, I don't think there's much more to show on this demo. I showed the performance aspect of it, and I kind of showed, you know, like what a setup might look like here, using like suspense and stuff. As I said, this example here of using a data component with the profile to use create resource is a little bit closer to a real scenario, and then the profile itself from the suspense. It's kind of cool how it just kind of all wires up and works for you, and then you just literally can take the same app and without any other code consideration have it pretty much client only, server only. Like other than the entry point, admittedly, other than the fact that I chose to start from the HTML tag rather than the div ID, like that makes a difference with client only versus client and server. But more that I was getting at, it's like all the different rendering modes all kind of work with the same app, right? And really trying to go for this isomorphic feel where you kind of abstract the details of how your data fetching works kind of into the resource API here. Like this fetcher here, I'm just using fetch. And in our case, I polyfilled node fetch at the top level, so it works on the same on both sides. But you could basically have it like, you could basically have your fetcher be something more like, oh, like once you do all this work, and you go, oh, like instead of maybe passing this URL, if you were passing something like, I don't know, users2 or something, or, like some other kind of encoded data format that you need, you could do something like import this server from SolidJS web, right? And then you could be like, if is server else this, right? And you could basically just go like, whatever, PG query, like some SQL thing, and then, select whatever, and basically take the same like request, and based on where you are, and because of the way the code splitting works, it should just not include PG in the client, because it'll see that it's not used. And then you can basically, if you abstract it at the fetching level here, you can basically set up the exact same app and have it just run on client and server automatically, all with the same imports and everything. That's the goal here. All right. Anyway, moving on to the next example. Undo this. So the last thing we're going to look at today is, let me open. What am I going to open? Let's go a little bit higher up. Development is solid start example. You guys are probably a little bit curious about this. This is me just playing around a lot. So, this isn't quite an empty project. And honestly, I'm probably going to have to rediscover it again while I look at it, because it's been a while since I've looked at it. But essentially, this is solid start, and I'm just going to run it in dev mode here for the most part using Vite. And when you install a new project, you basically get this folder structure, and we'll look at that. And yeah, so let's just going to look quickly if anyone has any questions. To recap, client versus streaming question, where the bytes saved on slow connection? Is it the lazy load of hydrated content is less bytes than the fetch bytes, or reduce support JS? Biggest part is that you can start your async requests on the server. Like when you do client side rendering, you're like, so basically you maybe have an app shell or something, and then you have to wait for the JavaScript to load in the browser, and then you do the request, and then your data comes in. With streaming, when you do the initial request to the server, you start doing the data request, and it comes in over the stream as it finishes. And the difference is, if there's always this kind of double cascade, right, where you have to load the HTML page and then you have to load the JavaScript. If your network is slow, you have to, like, the initial page, instead of taking, whatever, 80 milliseconds or whatever, suddenly it's 500 milliseconds. And then the JavaScript starts, and instead of being 80 seconds, it's also 500 milliseconds. And then you do your data request. And because, your network's slow, that's also, 500 milliseconds or longer, whatever. But if you, on streaming side, I can't do anything about the fact that your JavaScript takes 500 milliseconds or your page takes 500 milliseconds, because it's still going to take that long to load. But we started fetching the data right from that first request to the page. So while that 1,000 milliseconds or second is passing, that the client side rendering would have to like wait before it even gets started, we've already fetched your data and we're sending it along on that initial stream. So it's coming in with that, first 500 milliseconds. Like maybe it comes in a bit later, like it's 700 milliseconds or whatever. But like depending, like it shouldn't actually, like it depends, whatever. Like it's still taking a while to go over the wire per se. But my point is, by the time the JavaScript finishes loading, all the data is there. It's as if it was async, as if it was all present there. On the client side, at that exact same point, you're like, oh, now I have to go fetch all over the network, and it's a slow network. So you're literally doubling the amount of time it takes when you do that client side approach compared to streaming or even async rendering. Hopefully that answers the question. What is it going to take to implement real partial hydration? Depends on what our goal is. Like, maybe I'm being a bit of a stickler, elitist, or snob, or whatever. Like, I don't consider even necessarily like what people call partial hydration these days, like the island stuff, like actual partial hydration. Like if we wanted to do something like Astro does, which would be fine and useful in its own right, and thinking MPA style, we could do that. And I think it could even be, once I do a little bit of work around supporting multiple routes, which I need multiple async hydration routes, which I need to support Astro anyways. I think it's actually pretty easy for any framework to go and implement something like Astro for the specific framework. The tricky part about Astro is that you have to make it work for all the frameworks. But like any specific framework, that just wants to set up an island on the page, can do that. And then all you have to do is do a little bit something special. Like, I don't know, like I already showed you how I was doing it here. All we'd have to do is, instead of walking the tree, like I was doing, just go, okay, I know everything outside of this is going to be static. So let's just, instead of walking, let's just take the hit and do document query selector or whatever, and just grab those nodes and make that the starting point of hydration. Look at the template and make that call, because it's all very explicit. The difference, the only reason I don't do that right now is obviously it takes more work and more specific stuff. And Solid's optimized right now to do the walking, because walking like that is faster than query selectors when just doing hydration or rendering in general. So for the most part, once you're in the hydration route, you don't want to be using document query selector. You want to be doing you want to be doing like the first child next sibling stuff that I was showing off. But all it would take would be to kind of like recognize that you're in that mode, and just like basically treat everything as static until you hit a component that's registered like that. And then from that point on, just treat it as its own kind of sub app or something. There's a little bit more to it, but I believe that's all it would take. And even what we have right now, like as silly as it sounds, you can achieve something very similar, simply by using like tag template literals, or template literals, like to do your HTML tag and to do a string. And then how like when you use normal server rendering, you just like put in your entry point, just make multiple of those, right? Just like that's the poor man's version, right? If you want to get stuff like Astro's like intersection observers and stuff, you need to load a script on the page that does a little bit of extra there. So like my point is, it's not cheap and it takes consideration. There's a reason there's a team of people working on this, especially to support all the frameworks. I'm just saying, like, it's an involved problem, but not a challenging one. The only thing is you have to do the work. You have to decide that's what you want to do. Like, do you want to optimize for MPA, right? And my thinking is, if we can support like multiple hydration routes and stuff, like, why don't you just use Astro? Like, I mean, like, it already kind of handles the case. Like, I don't know if it has any. It doesn't seem to appear to have much overhead. I don't really know if that alone adds much benefit for what we're doing. I mean, if someone wants to make the framework, SolidJS is built on Svelte to do it. We could make like a kind of framework built on Solid to do this as well. Kind of like I was talking about, essentially. So it can be done. But if you want to know what I'm personally interested in, I want to see what I can do for single page apps. I want to see if there's other techniques we can do to reduce JavaScript load in a smart way. And part of this is probably because I know on the MPA side that anything I do won't be able to touch the work that Marco does. Like it's so much smarter and better in terms of analysis, and the amount of work to get there, like the support of the language specific qualities and the analysis, and like it would take us years, and maybe it's a worthwhile challenge, but as I said, are multi-page apps where you're going with this? Like me personally, I don't need to compete with myself, right? I'm already working also on a framework that is just really good at multi-page apps. So I kind of want to see Solid as being like something that's, you know, really good at single page apps. Like it's a Svelte or React competitor, right? It's you know, I think there's, or Vue or whatever, I think there's a lot we can do to reduce JavaScript there and do smart things for template loading. And maybe in the end, both approaches kind of merge or something, or we get to a point where you can kind of get best of all worlds. But I think it's most beneficial that we attack this from that side, because that's what Solid's good at. I think MPAs are important. I think that there's a lot of use cases for them. They just weren't the use cases why I created Solid. And when I put it up against, and when I consider that you can both use something like Astro, which does the trick already good enough, and then when I especially put it against Marco, which it's just not even close on the MPA side. Like it's so funny because, you know, some people talk about, you know, boasting and all that kind of stuff on the performance benchmark, but it's like Marco is so far ahead that I don't even feel ashamed of talking about it that way. Like it's just hard for me to be motivated. But I said, if someone wanted to make something, you know, and they would like the JSX and like the experience with Solid, I think there is space there. It's just personally, I feel like we could leverage Solid in different ways and benefit, like basically push boundaries in ways that no one's seen before in, you know, in terms of code reduction and performance and stuff, and just a different way that isn't islands. Anyways, I hope that answers that question. Yeah. That's like generalizing it. It's just, the truth of the matter is you can use Marco for a single page app if you wanted to, right? Like nothing's stopping you. It has all the pieces. The performance today on the client is like not amazing, but I mean, it's right up there with React and Angular, and those are popular. And then, as I said, the next version of Marco is going to have much better performance, much better. And I think, you know, after Marco 6 comes out, people might actually play with it with single page apps. But when you talk about multi-page apps and the types of optimizations, when you can put the streaming in conjunction with things like automatic partial hydration, you know, it almost feels criminal that you're not using that. And especially when you just consider the design philosophy of Marco, HTML first and all that kind of stuff, it feels like you're just building a website, because you're like, if most of your page is static, you want to start with HTML. If you're making an app, I feel personally that I want that control. I want the JavaScript for first, right? And that's where I've always sat, and that's where I still sit. You know, like these are, even though I work on two frameworks, like because of certain kind of use cases, I see that balance. But like if someone came to me and was like, "Oh, do you want to use Solid at eBay?" I'd be like, I mean, maybe for these kind of certain kind of little things here or there, but like for the main site, like Marco is like clearly a better choice. Like it's just not even, again, not even remotely close. So it's mostly Marco is optimized for this use case in a way that no framework is. It's you know what I mean? Like Facebook built for Facebook's problems, Marco built for eBay's problems. What's interesting is you could always take an MPA framework and use it as a SPA framework. So from that side, they have both bases covered. So you might be like, well, then MPA optimizations are what matter, right? But I don't think there's a problem. Generally speaking, MPA optimizations don't work with single page apps. You're basically just throwing it away. So it's not clear. It's not so clear cut, if that makes sense. Okay. So where was I? I was going to show you guys Solid Start. Yes. So welcome to Solid Start. So if you just install a new project, you would basically be looking at what I'm showing you here. I added a couple stuff here, like these terrible, terrible links, which are completely unstyled. And you'll see when I start this in a second. But essentially, Solid Start, what it does, and there's this little meta tag so that it knows that if you change anything in this file, to actually reload the whole page and not try and do like client-side HMR. I actually had to do a little fancy thing there because I was having some problems. But essentially, Solid Start ships with a bunch of basic components for you: links, meta, outlet, and scripts. And this handles the injection of stuff like the meta tags you use, and the preload links. And outlet is the routes that you use, and then the scripts are like the hydration scripts and all of that stuff. So with this setup, you don't really have to worry about all those other things. And the outlet, you're like, oh, what's this doing? Well, it's looking at your page structure. This is your classic file-based router in your pages here. Essentially, we have an index TS, and then I made a user list data here. And honestly, this is just me playing, so don't take too much from it. The data component, by calling it userlist.data, the file-based router automatically knows that this is the data component, the resource that it needs for here. And I'm going a little quickly here because I'm going to show how this works in a second. But essentially, yeah, you know what? Let me just comment out a couple of these and just give you that solid start thing, right? What is it? npm run dev -- open. Can't remember, although I'm full screen, so it probably isn't going to open it properly. Can't even remember. Actually, it's like, what's the README for? It's because I'm in npm. If I was using yarn or something, it'd be different. -- open. Okay, where is it? Probably opened it like in the wrong browser or something. There it is. Okay. And there's some extra links here I added, but this is just oh, I guess the counter is supposed to be there. Sorry, my bad. What did I do? I got too many windows open. Let me close that down. What's the counter doing? I got the look here because I actually did hijack some stuff. Okay, yeah, the counter is working perfectly normal. Sorry guys. This is my playground. So let's just add the counter back on our page. All right. More updated. Yeah, so here we go. Welcome to Solid server-side rendering. And by default, Solid uses streaming. Just makes our life easier. This part's abstracted from you. Your entry point literally is this point, and start is like a provider, but you can add your own providers around start and around your app. So like this just handles the details. There's, in terms of config, oh, I'm just using the defaults, but there's a few options here. Like you can go like prefer streaming false if you don't want to stream, and you can change your adapters. But generally speaking, this is kind of like the base setup here. So and in our case, I just loaded some CSS and in our root, and basically Vite handles most of the rest. So yeah, let's actually add a page here. I made this user list page, and I want to let's add a different page, because let's add what page should we add? Let's add a hello page. Okay, hello. Okay, so hello page. And what are we going to do here? Export default. And hello. And yeah, I know I already have a component called greeting, so it's not lost on me, but let's just kind of show how the router works in action here. Because, I mean, you guys probably have a fairly good idea of how this works, but if I just add this here, and then go like this, and we should now have a hello page. All right. Now we have hello in here. All right, so our hello is not showing. What did I do wrong? See, sometimes this is one of those things that I kind of I wonder a bit about with Vite, because I suspect that glob import, yeah, doesn't work. So there's some rough edges on Vite still. It's a little bit unfortunate, but here's our hi page. This is actually pretty nasty if you think about it, because obviously you don't want to restart Vite every time you add a new page. So there's some rough edges. I think that's a lot of reasons why these starters are taking a while. That being said, Vite is awesome, but we still need to kind of work through it. So, I mean, that's all it takes to add a page here. And you can add parameterized roots or whatever. Like if I wanted to, let's rename this to like, what do we want to call it? Let's just go ID. I mean, it's lame. Let's do this. And then let's change, we're using the router here. So what is it? Funny, import, was it use params from SolidJS router. See, there's still a little bit of loose ends here, but let's just kind of do some stuff here. I think it's just like this if my memory serves. I think I should be able to just go hi params dot hello if my memory serves correctly. So yeah, there we go. Hi, hello. That's funny. But obviously it means that if I put in something like my name, so we have the basic file-based router. It can be, we actually support things like nested routing too, and then you use an outlet component. Kind of, it's the same pattern all the way down. If you use nesting, then you put an outlet, and that's where the children go in. But for basic stuff like showing a list and then showing the detail view, you don't actually nest if you think about it, because you don't want, it's nesting is for sharing layouts more than anything. Okay, so let's show off something else. So I made this user list and user data thing is our kind of trick for code splitting, because the data gets part of the main package and then the list gets part of here, and this way we can kind of parallelize things. But one thing that I've been playing around with is I thought, what would it be cool if we just had functions here? So one thing that I haven't decided on it, but I was like, this kind of idea that we can basically, if you use this actions extension here, like .actions.ts, and I haven't finalized on this, you can actually just write a function and it basically expected to be, can be an async function as well, but essentially you just write a function that takes parameters and returns data. And essentially you just write this function, just normal like this. And then if you look here, I'm passing this as the promise essentially, because even if you don't write it async, it becomes async. You basically you import the actions. I did act for short, but I don't know who was I just being tacky. I don't know, whatever. Basically, it uses the name as a namespace for the file, and then basically you go actions.users. The name of your function. So see here, like get all, and then calling, since it requires no parameters and returns a promise, it's essentially just perfect for create resource. So I'm just gonna call this function, and what's cool about it is, let's go back. What did I kill? See, this is sort of what I'm talking about here. So I don't need to open it again. Keep on opening it. Let's just go back to the start. Yeah. Go to users. Here's our users, right? So what happened here? If you remember our previous example, and we have suspense and everything baked in, essentially, if I put a console log in here, let's do that, actually. Not that one, sorry, this one. If I just go console.log get all, what's got on? All right. Fresh. Okay. Maybe I'm not streaming the logs out. That's annoying. Okay. That's it, rough edges. Okay, so let's try a different way. My point is what's happening here is we've made this function. When the page gets server rendered, we should be able to see this view page source. We are actually streaming the data out. See, here's the data coming out. So it's fetching the data on the server and streaming it into the client like this, right? But if I go here, I'm gonna refresh, so you see that there is no streamed. It's not. Oh, it's because I'm on the wrong page. Sorry, view page source again. There's no stream data here. Okay. Now, when we go to users on the client side. Sorry, do that one more time. You will see get all called here, and you'll see the data fetch this way. So basically, the whole idea with this actions feature that I've been working on is essentially you just write a function like a normal JavaScript function, and whether it's called on the server or on the client, it doesn't matter, and it abstracts that whole detail away. So if you pass into a resource like I'm doing here, essentially it just works isomorphically, right? In this way, you don't have to like think too hard about writing an API. This isn't like REST controllers or whatever. Like you essentially just write the functions you need. And to kind of take this a bit further, I actually made an example where I made a greeting component. And let me do this. Let's add the greeting component back. And the greeting component, I showed a different. See, this was showing the use of an action to do some data fetching, right? But we can also use our actions to do things like mutations or something. In this case, this is just a greeting function. So we wrote say hello, and oh, what did I call it? I call it $sign here. I'm honestly just trying to play with conventions here, but I was like, okay, so greeting, say hello, Tom, then set greeting. So basically, it calls basically on mount. In this case, again, this is you'd probably use a resource for most of the stuff if you're kind of do this, but essentially I'm just showing that you can call it as a promise and then set it in a signal and see it. But then you could also, on the click, I called it with the value from the element and then set it on the signal. So this is a really simplistic example, obviously, but see, you saw hi Tom load in there. And now if I do this and greet, we should just, yeah, exactly, right? And we see the data come in. And what it's doing is, from the client side, we're actually fetching the call But also, as I mentioned before, if we refresh the page on the server, see, in dev mode, you sometimes get fun stuff about, you can see the CSS loading in dev mode on Vite. In prod, it's fine, but there's a flicker in Vite. Oh, right. It's because it always fetches on the client, because I set it to always fetch because it's on mount. Okay. But my point is basically you just basically specify any of these functions if you want, and then you can call them both sides. So it's really useful for if you don't really want to design an API, you can just use these to bootstrap, and because you know that they'll always execute on the server no matter where you call them, whether if you call them the server and the client, you can put your SQL or your stuff straight into these functions and then just use them to seed your resources or whatnot. That's basically what the actions feature is. Yeah. Someone pointed out to me that this is actually something that a framework called Blitz has. I wasn't aware of that, but apparently that's a thing. But this is sort of kind of one of the features for Solid Start. As I said, this is still a little bit rough, but essentially what you're seeing here is kind of a bootstrapped isomorphic experience where we can kind of swap in different adapters and then more or less kind of an authoring experience where you use file-based routing and then a few other extras. There's a couple other features that we have coming down the pipeline, some stuff we're working on around routing preloading, but essentially it's built on Solid's SSR solution, Vite, Solid App Router, and right now Solid Meta, though I'm debating changing it. As I said, there's a lot of rough edges you can see, but the core mechanics are more or less here. And because we use Vite, we get a lot for free, stuff like environment variables and whatnot. And then again, we can just go npm run build, and this will build our actual production build here, which kind of ends up here. So there's a server side, and then our assets, and then you can run npm run start. And then now we will have the production build. Yeah, of course it's broken. Sounds about right. Fun times. Okay, cool. That's about where Solid Start is. File path reduce is not a function. I'm not going to develop that right now. Essentially, stuff's been changing enough with Vite and whatnot that I would say it's still unstable, but I just wanted to kind of show you guys a bit of just a taste of like how the pieces kind of work together and what some of the features are. Honestly, it's still pretty early days, but I was doing some work on here. The project, as I said, when it's worked, I used that to make the Cloudflare demo. I don't know if you've seen this one. This one uses streaming and whatnot, and it's pretty fast. And basically, yeah. Anyway, we still got some work to do. That's the short of it. I don't know if anyone has any more questions. I didn't really have a ton of other stuff here. I just wanted to kind of introduce you guys to some of the SSR stuff and hopefully answer any questions people had. But there doesn't seem to be that much in the way of questions right now. I honestly, in terms of content, I'm familiar with what pieces are and what they are, but I don't know where people are trying stuff. I guess most of the time it's just a matter of like, because I haven't documented a lot of the SSR pieces, I imagine people haven't really tried them that much. And some of it's intentional. As you can see directionally, I want to get the HTML streaming in, and I want to get the multiple hydration routes in. And both of those are going to be really big for where Solid's heading to next. On the Solid Start side, we're doing more work with the router around preloading, caching, as I mentioned. I mean, you don't actually need that much in the way of features when you have Vite behind you. Honestly, if we add that and get rid of the wrinkles around Vite that I was showing off, and get the build configs more solid, you have a good enough foundation to kind of do stuff. I understand it's not as fully featured as Next, but like there's just a lot of things you get for free, basically, as long as you have a good solution for routing, metadata, data loading. You're mostly covered for the basics. But as I said, a lot of refinement and a lot of like niceties we need to kind of work around the Vite build. So if people are interested in helping out, I would definitely appreciate it. I haven't been giving Solid Start as much attention as I would like, but I think there's a lot of important things that still need to be worked on. As I said, the stuff around SSR. I've been doing some refinement on the reactive system recently, performance improvements, and I imagine that that will delay my personal work on Solid Start. But I guess if anyone's interested, please come by the Discord, volunteer, whatever. It's a bit of a mess. It's not that messy. I mean, it's just it could be a lot nicer, and there's a lot of kind of edge cases and things that break. So I haven't really set up a lot of tests per se. So that's like probably why it seems that every time, like every week, something new breaks without me even, realizing it necessarily. So I haven't been giving it enough focus. So yeah, and the server-side rendering needs its own documentation. I definitely agree on this. The biggest thing is because I imagine the APIs don't change, but the behavior is going to change a little bit when I add the other streaming pieces in. I've been hesitant to document it too far. I know there's a desire. I know people are really interested in this stuff, and it works today. It's just I know that some of the behavior will change, the documentation will change. This is just kind of the piece. So my lack of documentation is semi-intentional. I was really hoping to kind of just push Solid on its client-side merits initially, but the world has changed a bit, in the last couple of years, with things like Next.js, and you got to respect like the quality product they've managed to put together in terms of like ironing out all those rough edge cases. That takes a lot of work, and that's the piece that like we're missing. And obviously documentation will get people on board, but I think it's got to be like when it's ready kind of scenario. I really want to be able to present what I consider the whole solution. I mean, we can obviously add optimizations and stuff afterwards. Partial hydration for me is in that optimization category, or like variations on that. But I feel like finishing the streaming story and having multiple hydration routes in the client are just fundamentals for where things happening to basically support, as I said, islands or these streaming solutions. I think it kind of ties it up, Yeah, I don't know if anyone has any more questions. A little shorter stream today, but as I said, this one was based mostly on interest or whatever in terms of things. I knew people wanted to talk about SSR, so I figured I could show off a couple things, but I wasn't sure if there was any specific topics. But I think I think that there's just so much more, and I think maybe that's the challenge. I've been writing articles about this, but there's a lot of like people not even understanding what options are available to them, and so like a lot of frameworks have kind of taken on themselves to be like, oh, you want a server rendered solution? Here, one button press, here's a server solution, and it doesn't tell the whole story, but maybe that's good enough. I've been really working on the mechanics of it, right? I want to make sure that when we deliver our service solution, that it's top notch. Is the best way to put it. Okay, yeah, I was chatting here, kind of rambling, just in case any more questions kind of came in here over the last 5 minutes. But it looks like we are at an end here. If there's nothing else anyone wants to ask about, so I'm going to end the stream today here, and wish you all a good weekend. All right. See you guys and girls.